I think one of the most confusing things in surface area is which variable should you use, meaning do you use x, do you use y, and that's going to kind of depend on what r equals to. So I wanted to do one example to go through and show you how you might choose wisely, as in less work. So let's look at this problem. I want to take y equals 2 times the square root of x, which I have graphed here, from the values from 1 to 4, and I want to go about the x-axis. So I want to look at this problem and go, well, they've given me everything in terms of x. They gave me my function in terms of x, they gave me my limits in terms of x, so probably using my x as my variable would probably be the easiest choice. Right, so as I look and I revolve this around the x-axis, you can kind of see how I've got this dimensional image, and it's going to revolve around the x-axis. So your radius is always the distance from your axis of revolution. And from my x-axis, I'm going to draw my r, and since it's up and down, I know that equals to y. And I'm going to go ahead and label it, what does y equal to? Y equals to 2 times the square root of x. So let's say that one more time. R is a vertical distance, so that is y, and I know y equals to 2 square root of x. If I'm going to use y as my variable, I'm going to use y as my radius. If I'm going to use x as my variable, I'm going to use 2 times the square root of x as my radius. That's my only choices. So since I'm going to choose x, I'm going to let this be my radius. So my surface area, remember, is 2 pi times the radius times your arc length. So in this case I have 2 pi. My limits are given from 1 to 4. My radius is 2 times the square root of x because I want to use x. And now what is my arc length? Well, remember my arc length is 1 plus the derivative of the function squared. And again, since my function is in terms of x, that's going to be quite nice. So I have dy dx quantity squared. So if I have y equals 2 times the square root of x, that's y equals 2x to the 1/2. The derivative, bring down the half, subtract 1 from the exponent, I get negative 1/2. And if I square that, I'm going to get x to the negative 1, or 1 over x. So my surface area is going to be 2 pi from 1 to 4, 2 square root of x times the square root of 1 plus 1 over x. Now that integral, we could probably work through and solve it, but that's not the important part right now, is how to set it up. What do we choose for the r value? Let's take that same equation, same given information, but this time we want to go about the y-axis. So believe it or not, this is the same curve. The scale is just a little bit different so we can see it. So you can see that we're going to revolve this around the y-axis. So the first thing I'm going to do is I'm going to say, what is r? R is the distance from my axis of revolution. Since it's horizontal, it's x. Now, do I know what x equals to? Well, I could solve that for x. So let's see. If I needed to, if I divided by 2 and squared both sides, I know that is equal to x. But let's make a choice. Which variable do I want to use? I could go through and use y, but I think x is still the easiest variable to use because they've given me my limits in terms of x, my function is in terms of x. Just because I'm revolving around the y-axis does not mean I need to use the y variable. So if I look at my surface area, it's 2 pi from 1 to 4, same exact arc length as I had in the previous page because it's the same exact function, right? Same exact function. So my y prime squared is 1 over x. So what is r? That's the only difference. Again, really want to emphasize that I'm using my x, I'm using my x, so I'm going to just use x. And that would be that particular integral to solve. All right, let's look at this problem. This time, they've given us everything in terms of y. So we have this in terms of y, this in terms of y. So maybe this time, the variable that's probably going to be the easiest to use is y, right? So this is a parabola. You could sketch the graph, but let's just kind of say, okay, my distance from my x-axis, that's r, it's up and down, it's y, right? Since I'm going to use the letter y, I can stop right there. So I would need to know dx dy, which would be 2y. I would square that quantity. So my surface area would be 2 pi, limits 1 to 4. And remember, I'm using y, so that's my radius, times the square root of 1 plus 4y squared. And that's a pretty easy integral to solve. But let's do it again. And I'm only going to change one thing. I'm going to say, let's revolve around the y-axis. Okay, so the distance from my y-axis, wherever that parabola is, r is equal to x. But what does x equal to? Y squared minus 1. Because, again, I'm using my variable y, I want to use y squared minus 1. Why didn't I do that up here? Because I was using y and I already had it. Right? So this surface area would be 2 pi from 1 to 4. Arc length 1 plus 4y squared dy, same exact thing. The only thing that's going to be different is my radius, and that's going to be y squared minus 1. Now that would be a pretty tricky integral. We haven't learned how to do that yet, but that is how you would set it up. So in conclusion, draw your r from your axis. If it's this way, it equals to x. And if it's this way, it equals to y. Then ask yourself, do I need to know what x equals to? Do I need to take the function they give me and solve for x? Do I need to take the function and solve for y? Look at your information and choose the easiest variable.